Hello, I'm Ivan Tresoldi and I'm a Cloud Specialist System Engineer in the VMware Cloud Provider program. In this video, I'll walk you through the VMware vCloud Director and NSX integration. Let's start saying that service providers need to provide a way for their end users to consume networking and security related functions such as on-demand networks, routing, firewalling, L4 to L7 services such as load balancer, VPN, DHCP, with multi-tenancy and self-service. vCloud Director is VMware's multi-tenant infrastructure as a service solution. NSX is the network and security virtualization platform. This session covers how the two work together. Let's have an overview of the NSX services consumable through vCloud Director. First of all, I want to recap what an Edge Services Gateway is. The NSX Edge Services Gateway is a multifunction, feature-rich Edge virtual appliance. The Edge Gateway provides per-tenant Edge network and security services. It replaces hardware devices and appliances. The Edge Gateway is available in multiple form factors for scale-up or scale-down purposes. All services provided by the Edge Gateway are available through a common API and a user interface. High availability mode can be configured for the Edge Gateway. And finally, the Edge Gateway supports multi-interface and sub-interface, so VXLAN and VLAN trunking. The services provided by the Edge Gateway are stateful firewall, network address translation, load balancing L4 to L7, site-to-site VPN, L2 VPN, client-to-site VPN, static and dynamic routing, DHCP server, and DNS relay. Services provided by the Edge Gateway could be mapped to three NSX bundles. The NSX Base bundle provides tenant self-service capabilities for services such as SSL VPN, IPSec VPN, L4 and L7 load balancer, North-South firewall, network address translation, DNS, and DHCP. NSX Advanced Bundle provides tenant self-service capabilities for micro-segmentation with distributed firewall and dynamic routing. NSX Enterprise Bundle provides tenant self-service capabilities for on-demand hybrid cloud connectivity with the L2 VPN service. Let's now have an overview of the distributed firewall service, also known as micro-segmentation. Micro-segmentation protects workloads inside the virtual data center from lateral spread of unneeded or unwanted traffic. Leveraging only protection at the virtual data center perimeter grants little or no lateral controls inside the perimeter. Instead, if we apply micro-segmentation, we can grant lateral control inside the perimeter to all workloads. If we look at this diagram, we can see that with distributed firewalling enabled, every single virtual machine is protected by a firewall at the VNIC level. This is the so-called micro-segmentation. Let's see micro-segmentation in action. I'm logged into the vCloud Director user interface. Let's open the list of our organization virtual data centers, and let's select the T1 OVDC organization virtual data center. Deployed into this virtual data center, I have a vApp made of two virtual machines. If we look at the diagram, we can see that we have two vApps with a vApp network directly attached to an organization network, which in turn is routed to an external network. If we look at the details of the virtual machines, we can see that they are on the same network subnet Let's open a console connection to one of the virtual machines. And let's ping the second VM. The ping is succeeding as expected. Let the ping run and select the administration tab, virtual data centers. Right click on the organization virtual data center and choose manage firewall. This opens an HTML5 user interface. There is a transaction in progress between the legacy Flex user interface and a new HTML5 based user interface. The networking and security configuration is the first part of the transition happened, so all networking and security configuration are now made in this new user interface. As you can see in the distributed firewall section of the user interface, there is only a single rule, the default allow rule, which allows any traffic from any source to any destination, any service. Let's create a new rule. Let's name it T1 rule 1. We can select in addition to the traditional way of configuring firewalling, choosing IP ports, we can browse for vCloud Director objects and leverage vCloud Director objects for the rules configuration. This makes the configuration more easy to do. In this example, I'm going to choose a specific virtual machine as a source. I select the other virtual machine as the destination of the traffic. And finally, I change the action to deny for any service and any protocol. I save the changes. Let's have a look at our ping. It's not working anymore as expected. You can see here we have 8% packet loss. If we relaunch the ping, we are not able to ping the second server as expected. Okay, 100% packet loss. Let's try a different way to do the same thing. I delete the rule I've just created and I try to use security tags. Security tags are a way to apply tags to specific objects and then create dynamic rules that includes objects based on the applied tags. And this makes things more dynamic. It's simply a matter of assigning a tag to a specific virtual machine to obtain the result to have the virtual machine dynamically included in an already provisioned firewall rule. I create a tag named 01A. Let's imagine to apply this security tag to all VMs which have 01A in their naming convention for security or segregation purposes. Let's create a second tag, name 01B. Let's assign it to the second VM. After having configured the security tags, I move to grouping objects and I create two security groups. security group named 01A, which will include any VM with the security tag 01A assigned. And the second security group named 01B, which will include all the virtual machines with the security tag 01B attached. Here we are. Then back to the distributed firewall section, I can create a new rule. I can choose security groups as a source, and I can choose my 01A security group. Then I choose 01B as the target. Let's check before saving changes if my ping between the VMs is working as expected. It is working. Let's now choose deny as the action for this new rule and save the changes. Let's check our ping. The ping is not working anymore as expected. Let's try to relaunch it just to check. Correct, it's not working. 100% packet loss. So we have seen two ways to create distributed firewall rules. First way is a direct mapping between objects like VM to VM, and the second way by creating security groups which dynamically contains objects based on tags, on network position, on VM name. Let's go back to the main vCloud Director user interface. We are back to the T1 OVDC virtual data center. Let's select the Edge Gateway and we look to the external IP address assigned to the Edge Gateway. The external address is 192.168.103. So this is the external IP address of this Edge Gateway, accessible from the external side of networking. So we need to configure firewalling and NAT accordingly to this IP address if we want to publish services from the inside of the virtual data center to the external network. Let's try to publish a service. We enter the Edge Gateway Services, configuration. Again, a new HTML5 user interface will open. Let's create a NAT rule, network address translation, a destination network address translation rule. This rule is aimed to map an external network connection made against the external IP address of the Edge Gateway on the TCP protocol, HTTP port 80, to an internal port and IP. So 192.168.10.101, port 80. This is an internal web server I have already deployed. Let's save the configuration. Here we go. And now let's try to access our website pointing to the external user interface of the Edge Gateway. And here we are, our Nginx published externally. Let's delete the rule. And I want to configure now a different service. I want to configure a load balancer. So the first step is to create a pool. In this example, I'm going to expose in a load balanced way two web servers providing the same content. So the pool is a set of servers providing content to the load balancing service. I name my pool pool 1. I use round robin as a load distribution algorithm. I can choose between different algorithms. I want to monitor the availability of the service on my backend web servers using the default HTTP monitor. I add the first member to the pool. I must specify the port where I expose the service and the port I want to use to monitor. Let me add the second member of the pool. Okay, let's save. The second step I need to do is to create a virtual server. A virtual server is the actual service I'm going to expose to the internet, and it leverages one or more pools on the backend to provide content. I enable the virtual server. I give it a name. I select an IP address from the IP addresses available on the external user interface, on the uplink interface of the Edge gateway. I select the HTTP protocol, port 80, and I specify my pool 1 as the pool of backend services provide the content for this load balanced web server. Okay, we have our virtual server created. Let's go now in the global configuration. You have to enable the service and save the changes. A network address translation rule is automatically created by the load balancer service, so we should now already be able to access our external IP address and see the service provided by the two web services we have mapped in the backend. I want now to configure an hybrid cloud connection, so a logical layer 2 extension between two different vCloud directory instances. I have this vCloud directory instance on site A with the tenant 1 T1 OVDC who has created an organization network named T1 OrgNet RTD. I want to stretch, so extend logically on L2 to a different organization network created on a different vCloud directory instance, so in a different vCloud directory organization, in a different site. And this is the network, site B T1 stretch net. I want to stretch to the first one. To do this, we need to access the Edge gateway on site A. Select the Edge Gateway Services. We need to go to VPN, L2 VPN. We're going to configure this L2 VPN side as a server. We use this external IP address of the Edge Gateway and this encryption algorithm. I have already pre-populated, for the purpose of this demo, the peer site configuration details, providing the name of the interface of the Edge Gateway mapped to the organization network I want to stretch. So I have to enable the L2 VPN server. I can move to the second site. I select the Edge Gateway in the target virtual data center, and I select Edge Gateway Services. Then we have to choose VPN, L2 VPN. We need to select Client. We need to provide the remote L2 VPN server IP address. We must be sure to provide the same encryption algorithm. We must select the subinterface mapped to the organization network we want to stretch. We have to provide credentials for the connection. Under the Statistics tab, L2 VPN, we can see the status of the tunnel. Here we are, the status of the tunnel is up, so we have stretched the two organization networks. Let's try now to verify the connection. I open the console to a machine on site B. Let's check the IP address. It's 192.168.2.201. So let's open our first virtual machine on site A, and let's ping this IP address. And here we go. So the two sites are connected. This means that we have different virtual machines on different sites, on different vCloud Directory instances, on different virtual data centers, on different organization networks, but those different organization networks looks like they are the same L2 network. So this is the real hybridity we can achieve leveraging the L2 VPN service provided by the Edge Gateway. The same result can be achieved between Edge Gateway instance positioned in a virtual data center acting as an L2 VPN server and a standalone Edge Gateway appliance deployed on the customer premises on a vSphere environment. And in this case, NSX is not needed on premise. The L2 VPN appliance only acts at L2 VPN client and is a standalone appliance provided for free. And finally, I want to show you additional services configurable on the Edge Gateway, like the HCP server. In this case, I have specified an IP range mapped to the subnet defined on a specific organization network. So all the virtual machines configured to receive IP addresses from the HCP will receive an IP address from this DHCP pool provided by the Edge Gateway. And then under VPN, we have also the IPSec VPN capability. In this case, we are not talking about stretching the network, but this is a classic site-to-site VPN where I can provide communication between two different sites using different IP address ranges. We then have the SSL VPN functionality. SSL VPN is aimed to provide client-to-site connectivity, and it provides installation packages for Mac, Linux, and Windows users. And finally, we have the north-south firewall feature configured on the Edge gateway. In this section, you can create rules for north-south traffic, specifying name for the rule, source, destination, and the kind of services you want to block or allow to and from the entire virtual data center. And obviously, you have to specify for each rule the accept or deny action. When you select the source or destination, you can provide a general IP address or a CIDR, like in traditional firewall rules, or you can leverage vCloud Director objects specifying things like gateway interface, specific virtual machine, entire ORC-VDC networks, IP sets, or security groups. So you can group objects logically based on the vCloud Director inventory and create north-south firewall rules leveraging those objects. There is a section named Grouping Objects. In this section, you can create a set of IP addresses, set of MAC addresses. You can view the list of predefined services that can be used when creating rules. And then we have the list of our services group. All the application groups include set of different services to cover a specific domain, like all the services needed to grant access to a Microsoft Active Directory service. We have then a statistics tab when we can see all the statistics related to the firewall, to the IPSec VPN, and to the L2 VPN. And then we have the edge settings. In this section, you can configure a specific setting related to the edge gateway, like a syslog server, where to redirect edge gateway logs. You can specify if SSH connection to the edge gateway will be enabled or not. And you can configure the settings to manage the SSH connection, like the username and the password needed to access the appliance. We can now have a final look at the vSphere web client to see the mapping between the abstraction layer provided by vCloud Director and what exactly happens in the backend on vSphere. We have to log on into the vSphere web client, and we have to select the networking and security section. This brings us to the NSX configuration. First of all, let's have a look at the firewall section. One important thing to mention about the distributed firewall configuration is that a specific section in the firewall configuration is created for every organization virtual data center on which we enable distributed firewall. This is important because the service provider could leverage this section, and the automatic security group, here we can see the security group automatically created and mapped to this organization virtual data center. And in fact, you can see that the two Linux VMs used in this demo are automatically included in this security group, and the service provider could leverage this security group to provide managed services, like for example advanced security services like EDS or web application firewall, or client services like agentless anti-malware. So this is very important to highlight. On the other side, we have obviously the NSX edge objects deployed by vCloud Director. If we look at the names, we can recognize the name of the objects we've seen in vCloud Director. Then we have the logical switches that obviously map to the vCloud Director organization virtual data centers networks. And same as the edge gateways, if we look at the name, we can recognize the name we provided in vCloud Director when we first configure those networks. This concludes our vCloud Director and NSX integration video. Thank you for watching.